So let's look at the queuing system components. Queuing systems basically is comprised of customers arriving and customers leaving. Let's say they come to an airport ticket counter. The time they start forming a line or falling into the line, the time they leave the ticket counter, that is called a system or a service system. So when we talk about system, that means we're going to start with when they enter the line and when they leave after getting serviced. Okay? This is basically the line itself. So we're going to be talking about two components. One is the line and another one is the system. Queuing system analysis thinks about how do customers arrive at the system. The customer arrival rate, which means the expected number of customers that arrive during a particular period. The customer arrival rate can be any one of these three different rates. So it can be an exponential rate, it can be a Poisson rate, or it could be a constant rate. The customer arrivals can be also like they can come in as individuals, they can come in groups, how much patience they have, on all those things. We are not going to be considering these things. We are going to be considering only these. Okay? The service rate distribution is always exponential. So we're going to be considering the service rate distribution and the customer arrival rate. Those are the two things that are of interest to us. Arrival distributions, especially exponential distributions, can be looked up this way. So they can arrive at this period of time and then it can decay like basically an exponential format. And that is what this whole thing is all about. This equation is all about. Lambda is the arrival rate, which is the customer arrival rate. Okay? Now, one thing that we need to know, when we talk about probabilities, that means expected arrival, that is number of people or number of customers expected to arrive. When we talk about probability, we know from your other classes, we know that it's a cumulative effort. That means probability of 1 plus probability of 2 plus probability of 3 plus so on and so forth is the total probability. And if you want to find the probability of two people in the line, then you're looking at 1 minus the probability of 0 people in the line plus probability of 1 person in the line. Okay, so this, you need to know this really, really well to calculate the probability. So one more time, the total probability is P1 plus P2 plus P3 and so on and so forth. If you want to find the probability of number of people equal to 2 or more, then it is going to be 1 minus the probability of 0 persons in the line plus probability of 1 person in the line. If you want probability of 3 or more people, it is going to be 1 minus P0 plus P1 plus P2 and so on and so forth. That is the basic idea of probability, so that you can calculate how many people are going to, what is the probability of number of people standing in line. So let's take a quick look at this. We have a mean arrival rate of 3 per minute. Okay, 3 people per minute, 3 customers per minute. What is the probability of exactly one arrival in the next minute? That is the question. Then in that case, we're going to be using this equation. The probability of the next person arriving in the next minute is going to be equal to the arrival rate, which is lambda, times t, the time, which is 1 minute, to the power n. The n is going to be equal to how many times that you want, which is basically you have 5 as the n in this case. That is the number of arrivals. The 5 is a number of arrivals in some time period t, at the same time period t. So you know that there are going to be 5 people coming in the next minute. That is what you are thinking about. So that n is equal to 5. And if we put these in this equation, you're going to get 10%. So there is a 10% probability that exactly one person will arrive in the next minute. Customers come in different ways. Okay, we're going to be looking at basically just the customer arrival rate. This is just an information that you can go through. But anyways, we're going to be looking at the customer arrival rate, which is going to be equal to lambda. We're going to be looking at 3 different models. So I'm going to talk about these 3 different models, which is going to be, one is called single channel. Single channel is you have a server and a line is formed in that server. That is a single channel. So if you have 2 servers and then you have line and then you have 2 different lines, that is also a single model. Okay. A multi-channel single phase is going to be when you have 2 customers. So there is a line which is formed. This person goes here and then goes to this person to get served and things like that. That is model 3. So this is model 1 and this is model 3. Okay. So model 1 is a simple system, single channel. And the example will be a drive-in teller in a bank, 1 lane in the toll bridge. Even though there are 3 lanes, each one of them is single models or model 1s. Model 2 is a constant service time system. A roller coaster ride in an amusement park. It takes exactly 1 minute. So the customers arrive, they go through 1 minute, and then they get out. So this 1 minute, the service time is constant. So if the service time is constant, then you're talking about model 2. This can happen in any automated system. If there is an automated system, then you're thinking about model 2. Model 3 is a multi-channel system, a parts counter in an auto agency, or a bank where a customer comes and then he wants to do the checking account and then he wants to get a loan, so he goes to another person, that kind of a thing. That is a multi-channel. Okay, so we are looking at 3 different models and we'll be doing some calculations based on 3 different models. In all these models, lambda is the arrival rate, mu is the service rate, 1 by mu is the average service time, and 1 by lambda is the average time between arrivals. Rho is the ratio of total arrival rate to to service rate for a single server that is going to be equal to lambda over mu. That is rho. We always want to calculate LQ, which is the average number of customers waiting in line. We always want to calculate LS, which is the average number of people in the system, not in the line, but in the system. We always want to calculate the average time of customers waiting in line. We always want to calculate the average total time in system. So this four here are the crux of these four things, or the crux of our calculations. We'll be calculating LQ, LS, WQ, WS. In your book, there is a figure, and this figure gives you all the models and all the equations. So the steps for calculating in this chapter is, number one, you determine the model, whether it is 1 or 2 or 3. Then you apply the equations, which is found here in this figure. If it is a multi-model system, which is model 3, you can find LQ. See, the LQ is not here. Only LS is here. You can find LQ in a table, and I'm going to show you that table later on. Okay, and that is from that table you should be able to calculate LQ, and using that LQ you can calculate the LS. Okay, so model 3 is the only one where you need to use another figure and come back to this figure. Okay, so let's do some calculations.